Imagine you hired this really brilliant new intern, right?
Okay.
And for the first few months, they just sit behind this thick pane of glass in the lobby. You slide a request through a little slot, maybe asking for, I don't know, a quick summary of a report or a recipe. And a few seconds later, they slide the answer back.
Right, like a traditional chatbot. Very safe.
Exactly. It's incredibly helpful, but they are totally isolated. But now, imagine walking into that lobby, unlocking the glass door, handing that intern the master keys to your company's entire database, and just saying, hey, go ahead and reorganize everything while I sleep.
That is a terrifying leap in trust.
It really is. But that terrifying leap, that is exactly what is happening to our computers right now. Welcome to today's deep dive. Our mission today is to really unpack Aaron Rose's The Tech Reader AI Digest that just dropped on June 2, 2026.
Yeah, it's a massive piece.
Because, look, if you want to understand how your everyday relationship with your devices is about to just permanently change, the entire roadmap was just laid out at Microsoft Build 2026. So we are sorting through this absolute mountain of dense developer news from that keynote to find the exact mechanisms that will change how you work.
Because it's not just a small update.
No, not at all. We are talking about the massive fundamental transition of AI from being just this helpful little chat assistant to becoming the underlying autonomous operating system of our devices.
Okay, let's unpack this.
Yeah, and to really understand the scale of this shift, we have to start by looking at the, frankly, rather surreal scene at the Fort Mason Center in San Francisco.
Surreal is a good word for it.
Because this wasn't your standard dry software update. You had Microsoft CEO Satya Nadella kicking things off, which is expected, but then Jensen Huang from NVIDIA joins live, and Peter Steinberger, the creator of the Open Cloud project, takes the stage. Right. And all of this is underscored by this completely unexpected musical performance from the Chainsmokers, which, according to Aaron Rose's reporting, just left this room full of developers looking visibly confused.
I mean, a completely baffling musical choice, no doubt.
Big deal.
But honestly, the jarring tone kind of fit.
Wait, really? How so?
Well, because the core architectural arrangement they were making completely upends how we think about software. I mean, historically, computing has been binary. It's comforting, you know.
Right, you click a thing, it opens.
Exactly. You click a mouse, a file opens. You hit delete, a file vanishes. You are the master. The machine is the obedient servant. But the overarching theme of this keynote was unambiguous. Copilot is no longer just a chat interface where you type instructions.
It's basically running the show now.
Right. It is now a runtime environment. Agents are the OS.
So we're moving from you giving discrete, specific commands to a machine to the machine just acting autonomously in the background. But going back to my analogy, giving an AI intern the physical keys to your office means they might accidentally burn the building down.
Or intentionally, depending on the prompt.
Right. I mean, an AI that hallucinates or just misinterprets a prompt could accidentally delete a massive corporate database or completely overwrite a sensitive financial model. How is Microsoft physically preventing these autonomous agents from just causing absolute havoc on a corporate network? Enterprise IT departments must be sweating right now.
Oh, they have been. But what's fascinating here is that Microsoft used this event to introduce the exact concrete mechanism to prevent that nightmare scenario.
Okay.
It's called MXC, or Microsoft Execution Containers. It's this entirely new policy and security layer built directly into the Windows architecture.
Wait, hold on, stop right there. Because security layer can mean like a lot of things. Are we just talking about a glorified antivirus program that sort of scans what the AI is doing? How does MXC actually stop an agent from doing damage?
No, it goes way, way deeper than traditional antivirus software. MXC doesn't just watch the agent. It fundamentally traps it.
Traps?
Yeah, think of it as a hardware-level virtualization trick. When an AI agent wakes up to perform a task inside an MXC sandbox, it thinks it has full access to your computer.
Oh, I see where this is going.
Right. But MXC has actually spun up a completely parallel ghost version of your file system.
Oh, wow. So if the agent misreads a prompt and decides, the best way to clean up my desktop is to permanently delete 5 years of my tax returns, it's only deleting ghost files.
Precisely. The sandbox absolutely blocks the action from touching the actual physical hard drive. It can enforce strict read-only states.
Meaning what, exactly?
Meaning the agent can look at a sensitive document to summarize it, but the physics of the sandbox make it computationally impossible for the agent to alter the original file. And Microsoft proved this on stage with a live demo that hit the hardest at the entire conference.
Oh, the OpenClaw demo.
Yes, they took OpenClaw,
Right.
which is Peter Steinberger's massively popular open-source computer use agent, and ran it securely inside one of these Windows containers.
Which is huge because people have been terrified of OpenClaw.
Exactly. They showed it operating in total isolation, and Steinberger himself stood on stage and endorsed the controls.
That is just a brilliant maneuver. I mean, they took an open source tool that corporate security teams have been terrified of, locked it in their new virtual vault, and basically proved it was harmless. Aaron Rose noted in his digest that this is exactly what enterprise IT needed, right?
It's the holy grail for them.
Yeah, CISOs finally have the documentation they need to approve autonomous AI deployments because they can definitively say, hey, we can contain it.
The roadblocks for corporate adoption are officially gone. But, and this is a huge agent, but maintaining these heavy, virtualized ghost environments while constantly running highly active agents that are monitoring your system, that requires a staggering amount of processing power.
It's got to be incredibly demanding.
It is. Software infrastructure alone just isn't enough. You need physical silicon that can handle the specific ruling demands of autonomous operations.
Which perfectly explains the massive pivot to hardware at what is ostensibly a software developer conference. So let's look at the tools they announced to run this infrastructure.
Yeah, let's dive into that.
On the software side, the GitHub Copilot desktop app is moving into technical preview. So it's no longer just a code-writing plugin, right? It's an agent-native operations dashboard.
Right, a totally new interface.
You get a single view showing active sessions and background automations. But the standout detail was that parallel agents can now work simultaneously without conflicting, because each session runs in its own, and I'm quoting here, isolated Git work tree. Now, for the non-developers listening, explain what an isolated Git work tree actually means in practice.
Okay, imagine a commercial kitchen.
Okay.
If you have 5 chefs trying to chop vegetables on the exact same cutting board at the exact same time, it's a disaster. Fingers are getting cut
Total
off.
chaos, right?
Exactly. An isolated Git work tree gives every single AI chef their own identical fully stocked kitchen counter. They can slice, dice, and experiment with the code completely independently. And then, when an agent successfully finishes a feature, the system takes that completed work and seamlessly merges it back into the master project.
I love that analogy, but running 5 AI chefs locally on your machine sounds like it would literally melt a standard laptop.
Oh, it absolutely would. It would catch fire. And that brings us to the star of the hardware show, the Surface RTX Spark Dev Box.
The specs on this thing are insane.
Staggering. It delivers up to 1 petaflop of AI compute, features 128 gigabytes of unified memory, and the kicker is capable of running 120 billion parameter models completely locally.
Okay, hold on. We need some context for that. Because a petaflop is what? A quadrillion floating point operations per second? That is a mind-bending number.
It is. To put it in perspective, a single petaflop of compute power is roughly equivalent to stringing together over 50 high-end gaming computers from just a few years ago.
Right.
And cramming all of that processing power into a single box that just sits under your desk.
Okay, but wait a second. I have to push back on this entirely. Because for the last 3 years, the conventional wisdom has aggressively dictated that AI is entirely about the cloud.
That's been the narrative, yeah.
We've been told the future is massive server farms, stringing together thousands of GPUs in giant data centers out in the desert. So why are we suddenly pivoting back to local, under-the-desk boxes? And more importantly, why did Jensen Huang spend so much time talking about the importance of CPUs instead of GPUs?
That is the million-dollar question. And it was the core of Huang's explanation. It represents a massive shift in how silicon is actually utilized. Agent workloads require a totally different compute profile than the traditional AI chat interfaces we're used to.
How so?
Well, when you use a chat AI, you type a prompt, it zips off to the cloud. Massive GPUs crunch the data in a huge burst of intense activity, and it sends the text back. It's bursty. But agents don't work in bursts. They operate continuously.
Oh, because they're always on.
Right. They are constantly monitoring your screen, evaluating background tasks, reading local files, and making micro decisions every single second.
Ah, I see. So relying on the cloud for an autonomous agent would be like living in Los Angeles, but hiring a plumber in New York to fix your sink and having them fly back and forth every time they need to turn a wrench.
Exactly.
The latency, just the delay of sending information back and forth across the country every single second would make the agent completely unusable.
That is the perfect way to look at it. The latency would kill the experience. Plus, consider the privacy implications. Right?
Oh, sure.
You cannot have an AI agent streaming a live 204/7 video feed of your company's proprietary spreadsheets to a cloud server in another state. It's a massive security risk. So local agent execution isn't just some gimmick to sell new hardware. It is a fundamental requirement for privacy, speed, and continuous operation.
That makes total sense.
And because these agents are evaluating logic, managing file systems, and orchestrating tasks, rather than just generating massive blocks of text, the CPU, the part of the computer that acts like a traffic cop, has to step back into a central role alongside the GPU.
Okay, so developers get this absurd 1 petaflop supercomputer to build the future. But how do you and I actually interact with these agents day to day? Because I'm certainly not going to be managing isolated Git work trees.
Thankfully, no. And that is where Microsoft's strategy shifts from the developer to the everyday consumer and the corporate worker. Microsoft confirmed what they are calling the Copilot Super App, which is targeted for a summer 2026 release.
Right, and this super app unifies 3 distinct modes. There is chat for your standard conversation, cowork for desktop task automation, like having the agent organize files or schedule meetings, and code for software development. They are putting it all into one single unified interface.
Exactly.
And crucially, this ties directly into the brand new token-based billing model that went live literally the day before the keynote.
Yeah, the billing model is a detail that is so easy to overlook, but it's really central to why the super app even exists. Right now, billing by tokens, which is basically charging by fractions of a word or a computation, makes total sense to a developer who understands API costs.
Sure, they speak that language.
Right. But for an everyday user or, a corporate purchasing manager, it's incredibly confusing. Think of the super app like an arcade machine, and the tokens are your quarters. By unifying chat, cowork, and code under one roof, Microsoft can clearly meter your usage and deduct your quarters in a way that is legible and transparent to non-developers.
It simplifies the transaction, but there is a really bizarre detail surrounding the super app that Aaron Rose highlights in his digest. Leaked screenshots circulating widely before build showed that the super app was clearly finished.
Yeah, fully polished.
The interface was built, it was polished, yet when Satya Nadella got on stage, he confirmed it was coming, but he intentionally held back the demo. He flat out refused to actually show it to the audience. Why would a massive tech company announce a flagship product that reorganizes their entire user experience, but keep it hidden?
If we connect this to the bigger picture, it becomes a masterclass in strategic timing. First, Microsoft created a massive fragmentation problem for themselves over the last year. They threw a Copilot button into literally every single app, Word, Excel, Windows, Edge.
Everywhere. It was exhausting.
It overwhelmed users and made corporate IT purchasing an absolute nightmare. So they desperately need to consolidate it into one super app just to make enterprise procurement easier. But the real reason they announced it without showing it, that is entirely defensive.
Defensive against what? Like, who are they fending off?
The massive wave of tech IPOs hitting the market. Remember the timeline Aaron Rose laid out in the digest? SpaceX AI's global roadshow for a $1.75 trillion valuation starts tomorrow.
Tomorrow, yeah.
OpenAI is targeting a massive September listing. Anthropic is looking at October. The entire autumn of 2026 is going to be completely dominated by the hype narratives of these massive AI IPOs.
Oh, I see the game now. Microsoft knows these rival companies are about to go on global tours, promising investors the moon, dominating the news cycle, and basically trying to lock enterprises into massive new contracts.
Exactly. By pre-announcing the super app for summer 2026, Microsoft is effectively putting up a massive billboard for enterprise customers that says, hey, hold your budget. Don't sign a massive contract with anyone else during this IPO frenzy. The ultimate unified tool is coming from us in just a few months.
Wow. So they didn't even need to show the app.
No, they just needed to plant a flag in the summer calendar to completely freeze corporate spending.
That is incredibly calculated. It's not just about showcasing tech. It's about weaponizing a release date to control the global enterprise procurement cycle. So the super app and the new RTX dev boxes are clearly about Microsoft maneuvering to win the rest of 2026. But Nadella didn't end the keynote there. He ended it by putting a shocking stake in the ground for the computing of tomorrow.
Yes, the finale shifted entirely away from AI agents and focused on quantum hardware, but on a scale that just stunned the room. He announced that Microsoft's next-generation quantum chip, Majorana 2, is officially in production.
And here's where it gets really interesting, because they didn't just announce a vague research milestone. Microsoft publicly, on stage, committed to delivering a scalable quantum computer by 2029.
Which is wild.
To put that in perspective, quantum computing has famously been a running joke in the tech industry for 2 decades. The punchline is always that quantum is permanently 5 to 10 years away. To publicly state a hard 3-year timeline on stage at your biggest developer conference is an enormous gamble. If they miss that deadline, it's incredibly embarrassing.
It is a massive risk.
Okay.
But their confidence stems from a real breakthrough in how they are building it. The digest reveals that Microsoft used their own AI scientific research platform called Microsoft Discovery to massively accelerate the development of Madrona 2.
Yeah.
They literally used AI to solve the complex engineering bottlenecks of quantum physics.
Okay, so they use their current AI to design the next generation of computing. But Aaron Rose's digest gets very specific about the specs here. 1 microsecond quantum operations with a, quote, mean qubit lifetime of 20 seconds, sustaining up to 1 minute in some instances.
Right.
Break that down for us. Why is a 20-second lifetime such a massive deal? And how does their approach differ from what, say, Google or IBM are doing?
Okay, it all comes down to the fundamental architecture of the qubit, which is the basic unit of quantum information. Most of Microsoft's competitors, like Google and IBM, use what's called a superconducting approach.
Okay.
Superconducting qubits are easier to build initially, but they are incredibly noisy and fragile. Think of a superconducting qubit like trying to balance a sharpened pencil on its tip.
Oh, man.
Right. The slightest vibration or temperature change, and it falls over. The quantum state collapses in fractions of a second.
So you basically barely have enough time to run a calculation before the whole system just falls apart.
Exactly. Right. But Microsoft has always been on an island, pursuing a vastly harder method called a topological qubit. Instead of balancing a pencil, a topological qubit encodes information by physically braiding subatomic particles together.
Braiding them?
Yeah, think of it like tying a knot in a shoelace.
Yeah.
If you shake the shoelace or change the temperature of the room, the knot stays tied. It is inherently stable. That is why hitting a 20-second mean qubit lifetime is a watershed moment. 20 seconds in the quantum realm is an absolute eternity.
It's unheard of.
Right. It means the quantum state survives long enough to actually perform unimaginably complex, useful calculations before collapsing.
So Madrona 1, which they announced last year, proved the physics of the knot actually worked. And Madrona 2 is them basically saying, okay, the physics are solved. Now we are just using AI to scale the engineering. They are daring the rest of the industry to keep up.
And this raises an important question, as Aaron Rose points out in the digest. How on earth do Google and IBM scramble to respond to this aggressive timeline before the summer is out?
Yep.
Because if Microsoft actually delivers a scalable quantum computer by 2029, the implications for global cryptography, for supply chain optimization, and specifically for AI infrastructure are almost unfathomable.
It would literally rewrite the entire balance of power in global technology overnight.
Overnight, absolutely.
So what does this all mean for you, listening right now? Today, we unpacked how your everyday relationship with your computer is crossing a massive threshold. We are moving away from that comfortable, predictable, binary world of command and control. You aren't just going to be typing instructions into a chat window and waiting for a response anymore.
No, those days are ending fast.
Instead, you're going to be securely managing a team of autonomous AI agents. They will be operating directly on your local machine's physical hardware inside these heavily governed virtual ghost environments, anticipating your needs and executing complex workflows while you focus on bigger things. It is a fundamental leap from being a computer operator to being an AI manager.
And importantly, the tools to make that leap safe, like the MXC containers and the parallel Git work trees, are finally here. This isn't theoretical whiteboard planning anymore. The enterprise roadblocks have been removed, and the hardware is actually shipping.
But I want to leave you with a final lingering thought to ponder on your own. It's something that merges the 2 biggest announcements from this deep dive into an unexplored implication. Think about that heavy, virtualized sandbox we spent so much time discussing today.
The MXC containers.
Right. If an AI agent running locally in 2026 is powerful enough and unpredictable enough that it requires a heavily governed, locked-down MXC sandbox just to prevent it from destroying a standard corporate file system, what happens in exactly 3 years? How on earth do you build a sandbox capable of containing an autonomous AI when it is armed with the cryptographic breaking, reality-bending processing power of a scalable quantum computer?
It makes that thick pane of glass in the lobby look awfully fragile.
It really, really does. Thank you for taking this deep dive and exploring the future with us today. We'll catch you next time.